Hello, everyone, and welcome to Ecosystem Recycling. As energy and matter flows through ecosystems, matter must be recycled and reused as well. So on this first slide, we have this lovely picture of the water cycle. And with the water cycle, we can see how water goes from oceans to the sky and then back onto the ground and groundwater storage and stuck in the ice and going down through our rivers. And pretty much everything is reused and recycled. What do we need them for? Water, our bodies are 70 to 90% water, and that includes our cells. So we need it to carry out chemical reactions and to dissolve molecules and nutrients in our body. For example, one of the ones that we need the most, sodium chloride. Water will break this up into sodium ions and chlorine ions, which we'll then use for different processes. Carbon, we need to make carbohydrates. Carbohydrates are your simple sugars. They are what's used for quick, fast energy. Fats are our long-term energy storage, so we hold on to those until we truly need them. We have two different types of fats that we use, which is our unsaturated fats and your saturated fats. Those are the two major ones. We have some smaller ones like omega-3s, omega-6s that we'll go over next time. We'll go over another time. Proteins, these are what makes up most of your body. In fact, we'll eat protein from other animals, break down their amino acids, because proteins are made up of amino acids, and then use them to make our own protein. So your hair is made out of protein, your skin is made out of protein. Pretty much you are made out of a lot of proteins. And then, of course, DNA and RNA, which go over everything that makes us alive and is the genetic code for everything living. Nitrogen is needed to make proteins, DNA, and RNA. And phosphorus is needed to form bones, teeth, DNA, and RNA. So the top three elements needed by plants are nitrogen, phosphorus, and potassium, where for humans it's carbon, nitrogen, and phosphorus. And of course, we all need oxygen. But these four are the most important for humans, and these three are the most important for plants. So here we have the nutrient cycle. In a closed system, the sun's rays are not going to come in, but in an open system, we're going to have some that reflect back out and some that get absorbed into our system, which you can see here. So the nutrient cycles are closed systems where the energy for the food chain is an open system, which if you remember we talked about last time, we only get 10% of the nutrients passed down from each trophic level. And we lose some energy as heat. So the water cycle, we have three major steps of the water cycle. We have evaporation, which adds water as vapor into the atmosphere. The key word here is as vapor, so we don't lose water, it just gets turned into a gas. So heat will cause water to evaporate from bodies of water, soil, and bodies of living things. This includes me and you, which is why you'll hear a lot of people saying, hey, if you're thirsty, drink. And you know, if you're thirsty, you should drink. It's your body telling you it needs water. Transpiration, this is the process which plants take water through their roots and release water through their leaves. And then there's precipitation, which is how water leaves the atmosphere. It'll come down as rain, snow, sleet, hail, or fog. Now, one of the things that you don't see on here is condensation, which is when water starts to form as droplets in the atmosphere. So it's starting to get heavier and start to go from a gas stage to a more liquid stage. But these three are our key processes here. So here you see a picture of the water cycle. So we'll look at it through here. We have evaporation from oceans and from the lakes and from people and animals. We have transpiration, which comes from the roots of the ground, from the roots through the plants into the sky. Water vapor, which will be clouds, and then it'll go into precipitation where it will go back to the earth, where we will get runoff from the ground into our water systems. And then, of course, percolation, which water will go from either the ground or from oceans to into groundwater. Note that only 3% of the fresh water that we have is actually accessible to humans. Only 3% is accessible. The rest is in groundwater or is frozen in glaciers. So our influence on the water cycle is water depletion. We're using actually a lot of water at a time. And then water pollution. We do have some scientific ways and some people thinking of different ways to help get rid of this pollution. I'll show a video of it to you guys on when we have our project on the different cycles. But one of the things that there is right now is there's a couple of Australian scientists and some regular Australians who created this net in the water. And essentially, it's kind of like a bucket where it allows water to go in the bucket and filter out, and the trash to get caught into the filter. So it just filters through the water, and the water's allowed to go out, and they go every so often, pick up the net that's out there, dumps it out into their little trash collectors, and then put the filter back in. And so water can keep cycling and get clean, and all the trash that's on top floating on the water gets caught in their little filter. It's quite neat. So here's the carbon cycle. The carbon cycle gets, here we see we breathe it out, photosynthesis from the plants brings out oxygen, which through respiration we breathe in. So photosynthesis and cellular respiration, these are the two main steps in the carbon cycle. So the carbon cycle, we have death and decomposition. So when we die, the carbon that comes in our bodies goes down to the earth. The plants will take up, same thing with plants. When plants die, it's the same thing there. We do cellular respiration, which breathes out carbon dioxide. Plants breathe in that carbon dioxide through photosynthesis. We can have dissolved carbon dioxide in water. We can also have cellular combustion that will bring carbon dioxide into the atmosphere. And then, of course, we can get carbon dioxide in the ground, which can then create fossil fuels, which will then be used into combustion. Our influence on the carbon cycle, we have deforestation issues. There is a lot of plants that are being taken away, not only from us clearing it so we can do planting and other planting, ranching, and other things, but we also are creating more homes and burning more fossil fuels. So the amount of carbon dioxide in the atmosphere has increased, and we have less plants to do photosynthesis. So the nitrogen cycle, this is nitrogen fixation. This requires nitrogen fixing bacteria. And they are important in the nitrogen cycle because they change nitrogen gas into a usable form of nitrogen for plants. So we go from N2, so nitrogen gas, to NO3, which is nitrate, which is a usable form for plants. These bacteria will live in the soil or on the roots of beans, peas, clovers, and alfalfa, or legumes. This is a mutualism, which is a form of cooperation between animals. So the plants will supply bacteria with carbohydrates, and the bacteria will supply plants with the nitrate. So it's a positive relationship. So here we have a picture of it with animals when they die or they do waste, so urine and feces. That will bring nitrogen into the ground. Decomposers will then do ammonification, which will turn it into ammonia, which is NH3. Nitrification will take that NH3 and turn it into a nitrate. Denitrifying bacteria can turn this into N2 or nitrogen gas. Plants can use this in their roots through nitrogen fixation. And we have nitrogen fixing bacteria in the soil, which can then turn nitrogen gas back into ammonia or into nitrate. So we have nitrogen fixation, which is atmospheric nitrogen being converted into either ammonia or nitrate by nitrogen fixing bacteria and lightning. So lightning can turn it from nitrogen gas to nitrate. We have nitrification, which is ammonia being converted to a nitrate by nitrifying bacteria. Assimilation, which is plants' roots absorbing nitrates and using it to make proteins and nucleic acids, so DNA and RNA. Ammonification, which is when dead nitrogen-rich organisms and waste being converted into ammonia by bacteria, so it makes it available for plants. And then, of course, denitrification, which is when we have nitrate ions being converted back into nitrogen gas. So we have atmospheric nitrogen is when we have two nitrogen atoms bonded to each other. Ammonia, which is when a nitrogen and three hydrogen atoms being bonded to each other. And then nitrate, when three oxygens and one nitrogen bond to each other. So our influence on the nitrogen cycle, nitrogen is removed from the soil when plants are removed, so deforestation. It's released from vehicles causing acid rain and smog. And eutrophication. This is if excess nitrogen from fertilizers or feces get into a body of water, and this causes the level of oxygen to go down. So the phosphorus cycle is when phosphorus moves from phosphate deposited in rock to the soil, to living organisms, and finally to the ocean. This is not found in the atmosphere, so it cycles slower than the others. So when rocks erode or break down, small amounts of phosphorus will dissolve as phosphate, or PO4, with a -3 charge. And this will be in the soil and water. It will also be added to the soil through animal waste and when organisms decompose. And plants absorb phosphate through their roots. And this is usually the limiting factor in the ecosystem. This means that we find phosphorus in the lowest amount, which can limit plant growth. So here we have a picture of the phosphorus cycle. So we can get it through the consumption or death of plants or animals, which it'll then go down into these smaller mushrooms that are in the ground, which can then, when that dies, phosphorus will go back up, or it can leach into water. If it leaches into the water, we can get dissolved PO4 uptaked into plankton and then decomposed back into dissolved PO4 or down into sedimentation. And through geological uplift, so when we have new uplifting rocks and other mountains or other kinds of bodies, it can be uplifted back into the mainland, and then through the weathering of rocks or through runoff, it goes back into the water. So this is very slow because unlike the others, which end up going into the atmosphere, this one stays down into the rock level and into the main soil level. So our influence on the phosphorus cycle, it's removed when plants are removed, so deforestation. And then eutrophication, this is if excess phosphorus from fertilizers and feces get into a body of water. It causes the levels of oxygen to go down too. So here we see this lovely picture right here. And this is a body of water. And here's the thing with eutrophication. You can see it happening when there's a lot more moss showing up on lakes. Because what ends up happening is the amount of phosphorus or the amount of nitrogen starts showing up, and the algae that lives there starts to bloom. And when more algae blooms, the amount of oxygen that can get into the water lowers, and that means the amount of oxygen that's in the water lowers. So you're going to have less animals, you're going to have less fish, you're going to have more algae blooming, which then can increase the amount of nitrogen and lower the amount of oxygen in a water. And it's interesting because we can see eutrophication happening in some of the Great Lakes.